Hello, everybody. Oh, thank you for the clicker. My name's Norm Johansson, and with me here is Steve Roberts. We are both software developers on the AWS .NET team. And today we're going to talk about serverless development with C# and AWS Lambda. Very exciting. So yeah, a little background on that. Steve and I were at reInvent last year, and like every conversation we had with you guys was, when can we write C# Lambda? So we were very determined that we're not coming back to reInvent unless we could tell you guys we could write C# Lambda functions.
So here we are.
Yes, we made it back. So luckily to the great team back in Seattle, they made this happen. Now, the reason why I tell you that story is because this also is a prime example of how we build our backlog, what we work on at Amazon. It's basically you tell us what you want, and that helps prioritize some of these things. So if you see something you want, let us know. If you see other things people are asking that would be helpful for you, plus one that, and that's really what helps drive the backlogs that we work on. So today what we're going to talk about is we're going to give a very brief introduction to AWS Lambda. Judging by the round of applause, I'm assuming that most of you already know what AWS Lambda is, but I just want to give a little brief introduction there. And I'm going to choose why we chose to use .NET Core versus the traditional .NET framework, and then show off a lot of the new .NET Core Lambda tooling we've had to help you write your C# functions today. The talky part there should be fairly short, because for the most part, Steve and I are just going to be working in Visual Studio and showing you how to get started writing today. So Lambda is considered the compute part of the AWS serverless architecture, and it has zero administration here. In this world, we are not thinking about what EC2 instances do I want to have, what's the instance type, how do I set up my load balancers or auto scaling. In the serverless world, all that's taken care of for you. All you're really going to do is going to say, for my Lambda function, how much memory do I want to dedicate to that function? And Lambda has an event-driven scaling, meaning that Lambda is going to take care of making sure that your function has all the compute power it needs to meet the current demand on your functions. So as your function is being called by lots of parallelized requests, it'll make sure it has that compute power. And it works in the opposite, too. If, unlike an EC2 instance world where if you pay that hourly rate, even if you're not even using it, in Lambda's case, if no one's calling your function, then you're not paying for anything. There's no cost for idle time in Lambda's world. So really with Lambda, you're just going to upload your code and go. Now, why did we choose .NET Core versus the traditional .NET framework? Now, .NET Core is the new redesigned version of .NET with a focus on more modern applications and, in particular, cloud-enabled applications, which has a lot of great benefits for writing Lambda functions. First is performance. .NET Core was designed for speed, and it also was designed with a modularized design, allowing you, when you're writing your Lambda functions, to only include the parts of .NET that you're actually going to use, which gives you a much lower memory usage. And in Lambda's case, one of the factors on how much you pay for Lambda is how much memory you use. So if you can use less memory, you can pay Lambda less. Open source is another benefit of .NET Core. So we actually took the .NET Core source and we built it and validated it to work on top of Amazon Linux, which is the underlying platform for AWS Lambda. And by being open source, this is also going to allow AWS to be able to respond to any security issues that might come up with .NET Core. And cross-platform is also a major feature of .NET Core. We, as a room full of .NET developers, know that C# is a great and powerful language, but for the most part, we've all just been writing them on Windows. Now with .NET Core, we can write our C# Lambda functions on any platform, Mac OS, Linux, or Windows. So to get started writing in .NET Core Lambda functions, you're going to want to install .NET Core 1.0, which you can, if you don't already have it, there's the link there. Now, .NET Core 1.0 is the current LTS version, the long-term support version of .NET Core. If you've been following the release chain, the way they've talked about .NET Core, earlier this month, version 1.1 came out, and that's considered a current version or a fast-track support version. And the release cadence of .NET Core is to have several of these point releases with this fast-track, meaning much shorter support cycle, which will eventually then be rolled up into a new LTS, a new long-term support version. And that's when Lambda will start looking at when would we add the next version of .NET Core. Now, if we want to do your development in Visual Studio, which as .NET developers we mostly do, you would use Visual Studio 2015 and Update 3, And you'd also want to install Visual Studio 2015 Tools Preview 2. And that's the install that gives you the .NET Core tooling added to Visual Studio, which you can, again, download from that link up there. Now, when you're actually creating a Visual Studio project, you're going to want to target the .NET Core App 1.0 framework. And this framework allows you to use the .NET Core CLI to essentially do a .NET publish on that project, which will then copy your DLL and all of your dependent DLLs into one folder. Then you can just zip that folder up and send that up to Lambda, and Lambda can run your code. Now, we're going to show you some tooling later on that we have to actually make that process even easier. Now, when you're actually writing your C# functions that you're going to expose as Lambda functions, there's a few rules you want to follow. First, your methods can be either static or instance methods. Now, if you're using instance methods, you must have a default constructor in your class, because that's what Lambda is going to use to instantiate that class. Your function can take 0 or 1 input parameters, and can optionally take an iLambda context parameter. And that would be the last parameter in there. And that object is going to give you some runtime information about the Lambda environment executing your function. You can also write async methods as well. And in fact, if you're using our AWS SDK for .NET, you most likely will, because with that version, with our .NET Core version of the SDK, all of the operations that call AWS services are async. So you will return back a task, and basically what Lambda is going to do is it's going to wait for that task to be complete, and that's how it knows your Lambda function is done. Now, you can't use generic methods where you say, like, my function T, because at runtime, Lambda would not know what to resolve that T into. So to actually invoke our Lambda functions, we have a few ways we can do that. The first is we can have our Lambda functions be invoked in response to events coming out from other AWS services. For example, we can have our functions be invoked if new functions or new objects are loaded to S3, or if our DynaDB table is being changed, or as we learned in yesterday's keynote with Amazon Lex, we could have our function be invoked as part of a conversation. Below is a few of the supported services that have integrated with Lambda. Check the Amazon Lambda developer guide for the full list of services. The bottom two I wanted to call out because they solve some of the common requests we've gotten from .NET developers, which was I want to write a pure C# way to consume my Kinesis stream. And now with Lambda, I can write a C# Lambda function and hook that up as an event source to a Kinesis stream and do that. Also, is I have just some C# code that I will run once a day or once a week, and I don't want to set up infrastructure for that. Now with CloudWatch scheduled events, you can schedule when you want your Lambda function to run. Another way you can have your function be invoked is explicitly with any of the AWS SDKs. Basically, what the SDKs you can do is you create the Lambda client, call the invoke method, pass in the function name that you want to invoke, and a payload. And that payload is going to be translated into that input parameter into your Lambda function. And this works really well for our mobile developers who really want to focus a lot on their mobile app and not so much on building an infrastructure on the back end. So in this world, they can just build their Lambda function and then write the code in their mobile app to call the Lambda function there. And they can use Amazon Cognito to manage your AWS credentials and your identity. And the third way you can have your functions be invoked is with Amazon API Gateway. An API Gateway is considered the front end of the serverless architecture. This is going to allow you to expose your Lambda functions as an HTTP API. And API Gateway has a lot of great features built on top of that. So it can manage your authentication, your versioning, monitoring, and more. I highly recommend checking out the API Gateway Developer Guide on all those features. And again, that's our talky part. Really what we want to do is now get into code. So Steve, why don't you get us started?
OK, so the first function that we're going to write is going to demonstrate invoking a Lambda function in response to an event from an AWS service. In this particular case, what we're going to do is write a function that's going to be invoked when a new object is created in an Amazon S3 bucket. And what we're going to do inside that function is get the details of the object that was uploaded, and then we're going to use the new Amazon recognition service that was launched earlier this week to actually look at it if it's an image file, and then analyze it for labels, so things of interest in the photo, building, tree, person, etc. We're then going to write those labels back as tags on the S3 object using the support that was also announced earlier this week. So let's get started. OK, so here we are in Visual Studio. And if you've got the copy of the Visual Studio Toolkit for AWS that we released about 2 hours ago now, If you go to New Project, under the Visual C# tree here, you'll see AWS Lambda. So there are 4 project templates in Visual Studio currently. AWS Lambda project, a Lambda project with test, serverless, which we'll come to later. The test templates generate a solution that contains a test project as well as the source code, so you can do local testing. So I'm just going to choose Lambda project for now, and I'm going to call this function, application my image tagger. Click enter. That's going to take me into another wizard where I get to select a blueprint. So this is the skeleton code for my starter function. So you can see we currently have 4 blueprints in here. These will expand over time. And I'm going to choose the simple S3 function, then here, click finish. And that will generate me a solution with a single project in it. So let's go and take a look while the references are restoring of what's being generated. You'll see we have this function CS file. And you can see in here that, as Norm was just talking about, we have a parameterless constructor that we'll come to in a little while. But I want to draw your attention to line 12 first, this assembly qualified Lambda serializer attribute. Norm, do you want to go through what that does?
Sure. So we talked about how your function can take an input parameter. And by default, what you can pass into Lambda functions is streams and return back streams. But now, as developers, we want to work in typed classes. So what we've added is a mechanism where you can essentially register a serializer, either at the assembly level or at the method level, that will basically translate that stream into your typed classes. So here we have registered our Lambda JSON serializer, which is built based on Newtonsoft. And then in the Lambda function that Steve will show, you can see it actually takes in an S3 event object and not a stream.
OK, so let's go back to the constructor. You can see here that we're instantiating an Amazon S3 client. No great surprise, we're going to be responding to an S3 event. But if you've used our SDK for C# before, you might be wondering, well, where are the credentials? I normally supply some sort of credential object. When the function runs, it's going to run under the context of an identity and access management role. Okay? And that role will provide credentials to the function that the SDK will automatically get hold of. So you don't need to put credentials in here. In addition, I'm not specifying any region. The region can be inferred automatically from the region that the function is running in. So we can just use the parameters constructors. Scrolling down a little bit further, let's take a look at the generated function handler that we got. You can see here we're getting this S3 event object, and that contains details of the object that was uploaded, the bucket name, the object key, etc. And in the sample that gets generated, we just return the content type. So we're going to replace this with our new function. So I've already saved you the pain of me typing it in. I've gone away and pre-written it. So I'm going to copy these 2 files. The change to the project JSON file is just for adding the Amazon Recognition NuGet package for our SDK. And paste these in here.
And that's the SDK we just released yesterday, that package for recognition.
OK, so Visual Studio prompts to reload. So here we are. We're back in our function. So we still have the parameters constructor. The other constructor, by the way, is used by the unit test projects that we generate. So you can do local testing and pass in your own S3 client, if you were wondering. But let's take a look at the function handler itself. So here you can see what I'm doing is getting the object key. I'm going to take a look at the extension on that object. If it's an image file, Recognition supports JPEG or PNG files, then we're going to process it. Otherwise, we're just going to skip.
Now, Steve, I see you're writing to the console. Where do those go in a Lambda case?
So all the console output gets trapped and written into the CloudWatch logs for the function. So we'll actually see that when we actually run the function in a little while. Then we're actually going to take a look at an environment variable called confidence level. So when we invoke this function, we're going to give it a confidence level that Recognition is going to use to say, well, if the label that I detect or the object I detect, we're confident that it's higher than the minimum I've set, then we'll return that label. If it's less than that, then we'll skip it. That avoids us having to redeploy with a different confidence level if we want to change what we're doing. And then you can see that we're just going to instantiate a Recognition client. Again, we're not going to give any credentials or region information. We're going to form up the detect labels operation, giving the bucket name and the key of the object, passing in our confidence, and we're going to call Recognition. When Recognition comes back, we're then going to iterate through all of the labels it returned and apply those as tags on the S3 object.
And so tagging is the new feature that came out just the other day, right?
Yeah. So there's one other file I want to show you before we actually deploy the function, and this is this AWS Lambda tools defaults JSON file. So this backing file is used by the tooling to precede or pre-populate the deployment values for the function. So you can share this with your development team and have a consistent experience. When we run the wizard shortly, you'll see that it uses this to set all the fields on the wizard ready to go. The important thing to point out in here is this function handler you can see down at line 18. This is how you tell Lambda which C# method to invoke for your Lambda function. And the format is the assembly name, double colon, the namespaced class name, function handler, or the actual handler itself, method name. So my image tagger is my assembly name, my image tagger.function is my class name, and function handler is the C# method.
So basically, Lambda is going to then take my zip file that we uploaded, expand that out, and use that information to identify the entry point into my function.
Yeah. So that's it for the function. Let's deploy it. So to do that, I'm going to right-click on the project, and I'm going to select Publish to AWS Lambda. So this brings up the Lambda deployment wizard, and you can see that the values are already pre-populated courtesy of that backing file. All I need to do is choose my image name. So let's call this, my function name, my image, lost the ability to type, my image tagger function. Now, if this was a redeployment to an existing function, and I selected the drop-down there, the wizard would change. It would reach out to Lambda, get the current function configuration, and repopulate the wizard fields. So you do all your deployment and redeployment from one wizard in Visual Studio. I'm going to click Next. Now, a few moments ago, I said that the function is going to run in the context of an identity and access management role. And this is where we get to choose the role. So if I drop down the combo here, I can choose from either existing roles that I've created, or I can have a new role created automatically for me based on a managed policy. That can be an AWS managed policy, or it can be your own custom managed policy. Your choice. I'm going to go and choose my existing image tagger role here. And I said we were going to actually pass in an environment variable that is the confidence level that we're looking for. So confidence level, and let's say we're interested in a confidence value of 60 or higher. Okay? I'll just click upload. That's it. We're ready to go. So now we're going to invoke the .NET publish commands behind the scenes. We're going to package your function up, your class up into a zip file and send it to Lambda. And when that's done, we open the function view. So you can see here we have a number of tabs, test, function, configuration, etc. I could actually test the function directly from here. If I drop down the example requests here, for example, I can look at an S3 PUD. And I could scroll through here and change like the bucket name and the object key, click invoke, and then it would test the function.
So this is an example of the JSON that S3 would send to our function.
Yeah.
Okay.
We're not going to do that, though. We're going to do it live. So right now, our function is inside Lambda, ready to go, but there's nothing to invoke it. So what we're going to do is add an event source. So I'm going to go to the Event Sources tab, click Add, and you can see here we have the Event Source dialog comes up, Amazon S3. On the drop-down are some of the other services that are supported inside the toolkit for event sources.
And a lot of the other services that have integrated with Lambda, you would actually configure that on those consoles.
So I'm going to go and choose S3. The bucket that I want is already selected. I'm not going to give any prefix or suffix because I want to scan all image files that come in. I'm going to click OK. That will then wire up the event source for my function. So now we want some data to run on. So let's go away in the AWS Explorer and open up the bucket that we're interested in here. And what we'll do is I'm going to go away to some image files that I have. And I say let's choose the puppy, and I don't know, Norm's lot, and the lake and the boat. It'll do. Drag and drop those into the bucket. Click OK to upload them.
So now, as it's uploading it, this is actually going to trigger S3 events,
yep,
which is going to then cause our functions to be run.
Yeah. So now you're thinking, well, how do I know that the function actually ran, right? So let's go back to the image tagger function. And if we click on logs and refresh, we should see some log activity coming through from CloudWatch logs. This is the console writes that we've just been doing, okay? Let's just open up one of these and see where we're at. Okay, so you can see, oh, unable to load type. What did I do? One demo had to go wrong.
That, yeah.
What did I do wrong? Let's take a look.
Type the name.
My image tagger, everything looks good. Well, that's disappointing, isn't it? First demo. I don't know why I did. Let's check the other logs. Sorry?
We always have next year.
We always have next year, you're right, you're right. What did I do? Okay. Oh, hang on a second. Did I not change?
Did you mistype the name?
I mistyped the name. I'm sorry. I know.
Well, now we can demonstrate how you redeploy. So we all did this on purpose to show you how fast it is to redeploy.
All right, so my image tagger. So let's try that then. Let's try that again, shall we? Just rewind a couple of minutes. And I'm going to select the image. There we go. My image tagger. Next. And again, we've reached out to the function configuration. We've pulled back everything you already set. Let's click upload. There we go. OK, so now,
that's the redeployment process, fairly quick, just like the function go.
Let's just show the event responding. Let's take me and the koala, because I'm feeling a bit silly now. OK. Okay, so now let's go back to the tagger function and refresh the logs. Fingers crossed. There we go, it's running. Invoked on the koala and me JPEG, okay? So it's going to run a little while. Let's see if we can get a little bit more data out of it. There we go. So it's found 3 labels so far, people, person, and human. It hasn't found the koala yet. Maybe it thinks the koala's a human, I don't know, based on me. That also brings up another point, though. You'll notice that I uploaded the puppy, etc., and we also had some existing files inside the bucket. So we can actually test the function directly from the bucket. If I right-click on puppy and select invoke Lambda function, then you can see my function's already listed here. It's the only one I have currently.
And this is an example we talked about in the slide where you can explicitly invoke your function. In this case, what we're doing in the toolkit is we're using the .NET SDK to invoke our function, but recreating that JSON document that S3 would send to it.
So let's go and take a look at koala and me. Remember I said that the labels are going to be written back as as tags on the S3 object? Let's go see what we got. So properties on the koala and me image I uploaded. There you can see human, mammal, animal, koala. You picked it up. Adorable. I like it.
Very adorable.
That's me. And the puppy that I just ran should also now have some tags on it. Tags. There we go. Adorable. Oh, the puppy is more adorable than I am. Oh, fair enough. Yeah, okay. So let's go back to the slides and recap. So we showed how you can create a new Lambda project in Visual Studio using the new project templates, and how we apply serialization attributes so we can control serialization if we need to. We saw the handler format that I got wrong. So that actually brings up an important point. If you change your method name or your class name or your namespace, then you need to make sure you update the function handler. Okay. I'd like to say I did it deliberately, but I didn't.
We could have done it. We could have pulled it off.
We showed how quickly we can publish and redeploy from Visual Studio with the wizard, and how we can configure an event source and then do testing inside Visual Studio, either by directly invoking the function or waiting for the event to trigger through some other action. So let's move on. Now, Norm pointed out earlier on that one of the big features of .NET Core is that it's cross-platform. Okay, so if we're working on other platforms like Mac or Linux, we might have come across the command line, the .NET command line. So
you need to switch the...
No, I have another slide yet.
Oh, sorry, jump the gun.
This talk is so hot off the press. So we may be using command line tooling, right? We don't have Visual Studio available to us. Or it might be that we're integrating with a continuous integration system, right? And we just want to run commands. We don't want to put Visual Studio on our CI systems. So let's see what's available. So if we've been using, there we go. If we've been using something like ASP.NET Core on Mac or Linux platforms, you might have come across something called Yeoman. So Yeoman is a project skeleton ecosystem. It contains a number of generators that the community provides that generate the skeleton code for you, much like we just did inside Visual Studio. So that allows us to develop in any editor, on any platform, and it's a really easy install. It has a dependency on Node.js. You install using npm. The commands are shown on the slide. What we've done is written a generator for AWS Lambda. So you can install it, again, using the command on screen, and to run it is really easy. Let's go and take a look. So here I am on an Ubuntu Linux system, so I'm just going to log in. And here we are at a command line. So I've already installed Yeoman and all the necessary tools on here to save some time, so I'm just going to invoke the generator directly. Yo, AWS Lambda.net. Okay, so here we are inside Yeoman. You can see that we have a set of skeleton projects, empty function, simple DynmoD, simple S3, etc. These should look familiar. We just saw these in Visual Studio, right? We actually single sourced the Yeoman blueprints, or the Yeoman generators, and the Visual Studio blueprints from the same code base. So as the ecosystem grows, both will get that benefit.
One difference, though, is in Visual Studio, that list of blueprints is actually read all the time by our metadata system. With Yeoman, all the generators are always installed statically on your machine. So to get the new ones, you always need to update your Yeoman generator. So for this demo, I'm not going to do anything particularly special. I'm just going to choose an empty function, and I'm going to call it makeUpper. Reasons will become obvious. I've already set up a shared credentials file on this Ubuntu box, and I've called the credential profile default, so I don't actually need to give it a name. I'm going to skip that. But I'm going to use all the same SDK credential fallback mechanisms to find your credentials. Yeah. I'm going to give it a region, US East 1, generates the skeleton code for me, and then gives me a set of helpful hints about where to go next. So let's take a look at what was generated.
with Visual Studio Code. Now, one difference here over the Visual Studio thing, I hope you can all see that. It's a little bit tiny on the Explorer font, but you'll see that we have a test folder. Okay? In Visual Studio, we have the option of generating a solution with or without a unit test project. In the Yeoman generators, we give you the test anyway. Let's take a look under source, and you can see it looks identical. We have the function CS file. In this case, the function handler just takes the input as a string and returns the uppercase equivalent. That's why I called it make upper. Get rid of these prompts out here. Don't ask me again. It's amazing how I hit don't ask me again, and it asks me again every time.
Every time.
Every time. And then we also have the backing file, the Lambda defaults file. You can see here the function handler is in place correctly this time. And notice that the region's been updated. US East 1 is sitting in there because I just entered it by default. So let's think about tooling now, right? We said that we're integrating with the command line. How does that get turned on? Well, the clue is in the project JSON file. If I open the file, you'll see at line 15 a dependency on amazon.lambda.tools, version 100 preview 1.
Now, we mark this as preview because as in, the .NET CLI itself is actually under preview while they're doing their switching from the project JSON to the MS build. The code that we have in there we deem as production ready, but we will move it forward with the new project system.
And then I have that also as a reference for tools. So that now adds extensions to the .NET CLI for publishing and testing Lambda functions. Let's go and take a look at that. I'm going to open up a console here, and I'm going to move into the source folder, and we'll do .NET Restore.
And so that's going to pull in all of our NuGet dependencies,
Yep.
including that Lambda tools. Now, you probably already have them cached, so it's going to go pretty
Nice and
quick.
quick. Yeah. So now let's take a look at what commands we have available. So .NET Lambda, Lambda help. And you can see here we have a number of subcommands to control Lambda functions, so deploy function, invoke function, delete function, etc. We have commands for serverless that we're going to come to later on. And then the final subcommand, package. This is what you're probably going to want to use if you're integrating with a CI system. All the other commands will actually package up your function and deploy it to Lambda or the serverless deployment. Package just produces the artifact bundle. And then some other part of your pipeline, code pipeline or whatever, will then pick that up and deploy it out.
So I could use package with my code build and then send it through the pipeline.
Yes. All the commands also come with help. So let's take a look at the function that we're going to use to upload, deploy function. And you'll see it has a number of command line switches. These look familiar to what we just saw in that defaults file, right? So if I don't actually specify any of these, it'll attempt to read it from the backing file, right? If it needs something like the role, for example, and you don't supply it in the backing file, it'll prompt you for it. So pretty easy.
So by having that defaults file, I don't have to set a lot of these parameters on the command line.
Correct. So let's deploy our function. And we'll call it make upper. So just like we saw in Visual Studio, it's running .NET Publish to produce the artifacts to deploy. It's created the archive, it's creating the function. Now it wants to know what IAM role am I going to run this function underneath. So again, I have the same options I saw in Visual Studio. I can use an existing role, or I can create a new role from a managed policy. I'm going to use my existing make upper role.
And I could have specified the role of the command line, and I wouldn't have been prompted.
That's it, the function's created. So in Visual Studio, we saw we had those tabs where we could go and do a test invoke of the function or do things like, we can do the same thing at the command line. So .NET Lambda invoke function, make upper. Now we need to give it a payload, and we do that with the payload switch. And that takes a string that can either be a file name. If the file exists, we'll use the file content and send that on the invoke, or just a simple string. Okay. There we go. Came back with hello reinvent in caps. And it took 916 milliseconds.
So good thing to know when working with Lambda is the first time you're going to invoke your function, that's called the cold start, where essentially Lambda has to go procure the compute power for your function, get your code on the machine and ready to run. So we did all that in 900 milliseconds. Now, if Steve was to rerun this function again, it's all ready to go, so it will be a fast turnaround.
1.15 milliseconds.
So there we have the fastest two-upper cloud function ever.
Okay, let's go back and recap. So we showed that on platforms outside of Windows, we can use Yeoman to create our project skeletons, and with our new generator that you can install and easy to run. Again, we're developing with any editor. And deployment's done with a command line tool, with a NuGet package that we activate when you add the reference to your project JSON file, automatically downloads, and we have the commands to run. Cool.
Okay. So the next demo we're talking about is the serverless application. One of the features that Lambda came out fairly recently is called the AWS Serverless Application Model, which is essentially deploying your application with a CloudFormation template. But it's a much more simplified version of a CloudFormation template, where you can basically just define your serverless function all as one unit with all of the event sources. And by doing this as a serverless function with CloudFormation, we are actually able to deploy a collection of functions all together as one unit. And being CloudFormation, we can also include any other AWS resources that we need. If we need DynaDB tables or an RDS database, we can do all that in one function, or one deployment. So the demo we're about to go do is we're going to show off one of the blueprints that we added. It's for a blogging API. And that basically is we're going to have requests coming in from the internet, and our serverless is going to be fronted by API gateway, which is then going to be exposing our 4 Lambda functions on how you would manipulate your blog. And then those APIs are then using DynaDB as its source. And now this is our blueprint that you can also do as well. Now, how we deploy it is slightly different than the first demo we showed. In this case, we're going to use CloudFormation to drive the deployment. So basically, when we do the deployment, we're going to do the same building with .NET Publish, send that application bundle up to S3. Then we're going to load up our CloudFormation template, and then basically say, where do we go just put our bits in S3, send that template to S3, and then tell CloudFormation, go create our stack with that information.
OK, let's go do it. So we are back in Visual Studio. So you should be familiar by now. File, New, Project. And this time I'm going to choose the serverless application. Let's call this Demo 3. OK. Now we're going to set of blueprints for serverless applications. We currently have 2, an empty one and a blog API. So let's choose the blog API one. Click Finish. So this time, let's take a look at the function CS file that was generated. Whoops, don't want to go there yet. There we go. So you can see pretty much similar to what we saw before. We have the Lambda serialize attribute in there. We have our parameters constructor. And if we scroll a little bit further, you can see here's the first of our functions, get blogs async. Make a little bit more room here. And then we have a second one, get blog async. These will be exposed to our Lambda functions. And they're taking API gateway proxy request objects.
Right, because we are going to have all of our Lambda functions be fronted by API gateway as a proxy. And what that does, API gateway is going to take the whole HTTP request object, mark it as a JSON document, and pass it into our function. And then we are using our typed classes. The API gateway request proxy is one of the Lambda or NuGet packages we released today that has that in there. But we don't actually have to do JSON parsing in our functions.
So serverless template file I'll come to in a minute. Let's take a look at the defaults file that we generated. You'll see there's some differences here. Before we had those function settings. Here now we have an S3 prefix setting. This is where we're going to upload the content to S3. And then a reference to the template file name and any template parameters that we want. But other than that, its function is the same. So let's deploy it. Right-click on the project, publish to Lambda. Now this time the wizard has changed, right? Because we're not deploying a function, we're deploying a service application containing many functions. It just wants to know what stack name do you want. It can be an existing stack or a new stack. So let's put in a stack name of Demo 3. And it wants to know what bucket do we want to upload the content to. And that needs to be in the same region as the stack. Now the serverless template that we're using has been parameterized for the DynamoDB table that we're using. And we're going to use the same table in a couple of demos. So we've already pre-created it. So in the template parameters, we've actually had the option to allow us to specify if we want to create the table or not. So I'm going to turn that table off. But I am going to give it the table name of blog. And then click Publish.
So again, same example. We do publish, build everything up, send that to S3, and then we're going to go and create our CloudFormation stack.
Now notice that we create the CloudFormation stack with a change set. This means that when we do a redeploy with a change set, CloudFormation only needs to look at the things that have changed. It doesn't have to rebuild the whole thing. Okay? Once the deployment's done, you'll see that the stack view opens and the stack creation is in progress. So while that comes up, let's go and take a look at the serverless template file. And you'll see it's a CloudFormation template. The key difference, though, is at line 3, this transform statement.
Right, so we mentioned how this is using the new AWS Serverless Application Model. And that transform is basically going to let us write what we'd call meta resources in our CloudFormation template. So if we look at that get blogs resource type down there, you can see that that is a type AWS Serverless function. And there is no AWS Serverless function resource type. What actually happens by that transform is it breaks it down into the, here's my Lambda function, this is my IAM role, this is my API gateway REST, and hooked up all those event sources. So it's a much more compact way for us defining our serverless application.
Just like we saw in the function demos earlier on, you can see some familiar things here, memory size, timeout, role, etc. But there's a new one at line 42, code URI.
So that's the property I talked about. Once we uploaded the bits to S3, we basically, in our tooling, read this file up in memory, go fill in all those code URI properties to that location we just put your code in, and then take that modified template in memory and put that up to S3 and tell CloudFormation, go begin the deployment process.
So it never changes the original template?
No, the template is yours to modify and add any other bridges. So this is our CloudFormation editor, which has a lot of features of IntelliSense and validating you can use to add more AWS resources on it.
Yeah, that's the key takeaway here, that although we have this serverless function pseudo type in here, anything you can do in a CloudFormation template today in terms of spinning up resources and controlling them, you can do with serverless application templates as well. So let's go and take a look at our stack. It should be up and running. And there we go, everything's created complete. Let's go and take a look at the resources tab here, and you can see that the template resources that we spun up are a lot more than we actually had in that template. Okay, those pseudo functions have expanded out to create the necessary resources that we need.
Yeah.
So let's go and look at our application running. And I'm going to click this URL. This is the root URL of our app, so click copy.
That's the root URL of our API gateway prod stage.
So I'm going to jump away to Postman, HTTP testing tool. I'm going to paste in that.
So Postman is just an HTTP API testing tool that we like to use for testing our functions. And so this is our first time running it. So again, it's that cold start where Lambda is going in and procuring those computer resources.
And there's our blog data that's just come back. So we have 3 blog entries. So let's just do that again, just to illustrate again the difference between cold start and warm start. A bit near instant. Okay. So earlier on, I showed the command line tools. Yeah. That's where you would use the deploy serverless variants on a server. So you can do serverless application development on non-Windows platforms as well.
Because I don't think it's not, we mentioned, but all that deployment mechanism you see we've added to the toolkit, this is the same thing in that Amazon Lambda tool. So anything you can do in Visual Studio, you can also do using that tool.
All right, so go recap. So we walked through how to create a serverless application inside Visual Studio. And we looked at the serverless template file and those pseudo resource types for functions. And that lets us expose our Lambda functions as a HTTP API with deployment via CloudFormation, plus all the capabilities we have in CloudFormation today for controlling our resources.
Okay. So for our final demo, what we've been thinking is, if you've been writing ASP.NET Core applications in the past, and in particular ASP.NET or ASP.NET applications, you know there's already a built-in framework for Web API. And so with that framework, you basically define controllers, and you have attributes for routing and attributes for which HTTP method and where to get the data from. And there's a large ecosystem already on this framework. You can add middleware. There's lots of extensions on it. And so we thought, wouldn't it be great if we could just run this on Lambda, and you could just reuse the already existing ecosystem instead of learning a new programming model. So what we've done is, using the new API Gateway proxy integration feature that came out this fall, which allows you to essentially forward all requests to one Lambda function, we can do this. We have a Lambda function. It's going to use our new NuGet package that we just released today as well, called Amazon Lambda ASP.NET Core Server, which is currently in preview because we've really just kind of scratched the surface now what you can do with this, right? We've basically turned this on, and we know we can do Web API, but this is a lot of things we can do. So let us know what you can find to do, and we're going to keep working on this. But so what we're doing in that Lambda function is using that library, we are going to then take that JSON document that comes from API Gateway and transform it into the classes that the ASP.NET Core Framework understands, and then pass that on and let ASP.NET Core Framework do all the routing to your controllers. And then on the way back, we're going to marshal the response of ASP.NET Core Framework back to what API Gateway understands. So the 10,000-foot architecture view of how ASP.NET Core web applications work is essentially requests are going to come in from the internet. They're going to go to IIS or Nginx on Linux. They're going to then talk to Kestrel, which is the ASP.NET Core web server. And that's doing that marshaling of what requests look like from there to what ASP.NET Core Framework understands, which then takes care of the routing to your controllers, your code. So what we've done is essentially replace those first two boxes. Instead of IIS, we're going to use API Gateway as our front end. And instead of Kestrel, we're going to use Lambda to do all that marshaling back and forth, leaving ASP.NET Core Framework alone, and most importantly, leaving your controllers alone. So you keep that the same. So Steve, let's see if we can do it.
OK. So here we are back in Visual Studio, and this time I've got the project preloaded. So this is a web API, ASP.NET Core Web API project that I could have got from File New Project. The only change that we've made so far is that we've added a blogs controller. Right? This is going to talk to our blogs API.
Yeah, so that blog controller basically has the same behavior as the previous demo.
Yeah. You'll notice we've left the values controller in that was generated from the project template. We're going to use that shortly. And if we look at the program CS file, we have the regular ASP.NET startup.
Because this is how, when you write ASP.NET Core applications, it's basically a console application. And in that program main is where you're bootstrapping the ASP.NET Core framework. And that's really the part that we need to replace for Lambda.
So let's get started. So the first thing I'm going to do is turn on the new server support. So I'm going to add a reference to the Amazon Lambda ASP.NET Core server. OK. And then I'm going to add a new class to the project. That's going to represent our Lambda function.
So we can have the Lambda function, but again, it's still going to be a console or a web application, so we can run it locally and then deploy it to Lambda.
Inside the Lambda function, I'm going to derive that from one of the classes inside that package I just referenced. Lambda Core server called API Gateway Proxy Function. Now, this class has an abstract member that we need to implement. So we'll hover over and implement, and you'll see it's an initialization statement. So what I'm going to do now is go and take the parts of the initialization statement that I want.
Because we don't need IIS or Kestrel, but we do want to specify where the content root is at and where our startup class is so that we can add all of our ASP.NET Core services to our application.
Paste those in. We'll fix up the namespace for the directory there and just make it a little bit tidier. And then I've got one more thing to add, .use API Gateway.
And so that's going to be, that's basically tell ASP.NET Core Framework, this is our server. It's not Kestrel, API Gateway is our server.
Now, if I right-click on the project at this point, you'll see that there's no publish to Lambda yet. It still thinks it's a web API project I can publish to Elastic Beanstalk, right? So we've got one more thing to do. We're going to add on the Lambda tools. So go back to Project JSON, and we'll add in a reference to the tools assembly.
So basically what we're doing in the toolkit is we want to basically we support anything you have. So what we do what we do to turn on their tooling is to see, do you have a dependency on Amazon Lambda tools? If you do, then we are assuming this is something you want to deploy to Lambda, and that turns on our publishing tools. Now, this package we're adding is a build project, so it's not going to be something that's affecting your publish. It does not get included into there. It's just something that we use for your building. And now Steve's adding it to the tools section because that's then what also makes it integrate with the .NET CLI.
OK, there we go. So if you right-click on the project now, we have published to Lambda, or we're set to go. In fact, why don't we just deploy this as a function?
Let's do it.
So we'll call this.
Now, we don't have a backing file now because this is the plain file. We don't have that defaults file. And that's why a lot of these fields are blank. It's the advantage of having defaults files. We don't have to always set those up. But we do have some IntelliSense in the editor to help Steve not mistype another function there.
So here we go. I'm going to choose the role that's going to run there. Let's go our blog platform role. Everything else is good to go. Just upload.
So this is doing the regular Lambda deployment. So it's basically sending it to there and creating our function.
Yep. There we go, inside the function here. And in fact, we can do a test invoke straight away. So let's drop down this and choose the AWS proxy type.
And so this is that JSON document that API Gateway basically has to represent the HTTP request. And it's what that NuGet package is reading to translate into what ASP.NET Core understands.
So I'm going to change the method to get. And then if you remember, I said that the original values controller was still present. So let's invoke that. So API/values, hit invoke.
I think you missed the click.
I think I missed the click. There we go. OK.
And again, since we just deployed this function, AWS Lambda is out there procuring our resources, getting our functions on there, and then getting our function vote.
There we go. Let's pretty print that. There we go. So we've got 2 values back from the values controller.
So here we have the whole entire ASP.NET Core framework running as a Lambda function. We can do it.
Because I can, I'm going to invoke it again. But we're not finished.
No.
So our blog API, obviously right now we're exposed as a Lambda function, but we don't have that API gateway front end that we're looking for, right? So we're going to turn this into a serverless application. So what I'm going to do is right-click the project, choose Add, Serverless Template.
And so this adds a default version of that serverless template, which basically has one function set up as that proxy. You could obviously customize this and should customize this to your needs.
So I'm going to go away and swipe the handler.
Because by default, we don't have that function handler in there, so Steve needs to put it as their actual function handler of our Lambda function. And I don't think the actual implementation of the function is in the base class.
Yes, I'm going to go show that in a second. So what I'm actually going to do now is deploy this, and then we're going to deploy it as a serverless application. So the wizard will change, and we're going to call this our blog API. The bucket's fine. Our template isn't parameterized, so there's no extra things for the wizard to show. You just click Publish. Now, as Norm said, that I called that class Lambda function, but there was no actual Lambda function in there, right? Let's go and see where that is. All the change sets reviewed. And the stack will start coming up.
Always
Any moment now. There we go. Creating progress. So let's go and take a look at the Lambda function. So you see I derived from that API gateway proxy function class. If I hit F12 on that to navigate to it, you'll see there's a function handler async. So where's that? Well, on GitHub, there is a new AWS Lambda.NET repo that we published this morning.
And this is, I highly recommend you guys check this out. Again, all the steps that we've been walking through on setting up this thing, we'll eventually turn that into a blueprint, but right now we have those on the Git packages. And so all of the new Git packages that we released today, including the Lambda tools, this ASP.NET Core, and all the event packages are in this GitHub repository. And this is a place, if you've got issues or anything, let us know.
So there's a README in here that goes through a lot of what Norm and I have been talking about this morning. Let's take a look at the actual implementation of that class. And if I scroll through here, Norm, you wanted to have a few words about the constructor in this.
Yeah, so I mentioned when you write instance method, you have to have a default constructor. And what's useful about that is Lambda is going to always reuse that same instance for every function invocation while it maintains that compute resources. So if you have any heavy lifting you need to do, like in our case, we need to bootstrap the ASP.NET Core framework. We don't want to do that in a per function invocation. We do that as part of the constructor. So then in the actual function, all we're really doing is doing that, serializing it, and then passing it on to the already bootstrapped framework.
Okay. Let's take a look at the actual function handler implementation. There we go.
So overall, it was actually not that much code to do it. So.
No. Let's go back and take a look at our stack. And it's launched. We're good. So this is the root URL. So we're going to copy that, and I'm going to jump away to Postman again, and we'll post in this. But this time I'm actually going to add on API blogs. Enter. Now, it won't surprise you to learn it's the same blog data that's coming back, but because we haven't actually done a put. There we go.
There we go.
And then we do the same.
So here we have a ASP.NET Core framework that we deployed on Lambda, and it is exposed to the internet. And overall, I think very few amount of steps.
Yeah, there we go. Let's recap. So I think we've just done the recap, right? We took the ASP.NET Core Web API project, made very few changes to it. We didn't change the controllers at all. Deployed it, used API gateway proxy integration as our front end, through to Lambda, through to our controllers, using that new NuGet package that we published this morning. And the handler source code and everything is all there on GitHub.
And again, check out that GitHub repository and let us know what you think. So that's most of what we want to show. Here's some extra links to get started next. Again, we just released all these bits this morning as part of the keynote, so you need to get the latest Visual Studio, which you can get from there. Our GitHub repository we just made public this morning. Steve and I contribute a lot to the .NET developer blog. When we get back to Seattle, we will have a lot of things to write about when it comes to .NET Lambda. And check out the the updated Lambda developer guide and the AWS Toolkit guide. Here's some other sessions that you might find related or interesting as part of the serverless architecture. Some of these have probably happened, but remember, all these sessions will be up there on YouTube. And with that, thank you.